9E number 1, the scatter diagram in figure 7 shows stripes. So figure 7 is back on the previous page, 151. Why are there a whole bunch of horizontal stripes? Do you guys see that? The X's are spread out all over the place, but the Y's are in these horizontal stripes. Why would that be? So do we really think that there were a whole bunch at 2 million and none at 3 million? No. So why are there only numbers at 2, 4, 6, 8, 10, 12, and what would that be? What's that? Yeah, how accurately can we measure millions of years into the past? Not very far. And we're kind of guessing, not totally guessing, but if I said, well, that was 2,767,521 years, 18 weeks, 3 days, and 5 hours, right? We just can't measure that accurately. So they've rounded to the nearest 2 million years. Okay? So the horizontal stripes are a result of either rounding or estimating. Is that what the back of the book said? Something like that? Oh, good. Maybe I know what I'm doing. Number 2, is the correlation in figure 8 ecological? Do you remember what ecological meant? All right, the definition for ecological is back on page 149. Ecological correlations are based on rates or averages. They are often used in political science and sociology, and they tend to overstate the strength of an association. So, you guys watch that video, the Swedish guy with all the dots? Did you guys watch that? Wait, a whole bunch of you were gone that day, right? Is that the day everybody was gone? Okay, we might need to rewatch that because it's pretty cool. Anyway, when you look at smoking rates of people inside countries and you graph them as countries and not people, then the correlation shoots way up. So, for instance, on page 149, we have some A's on that figure 6, and we have some B's, and we have some C's. And the association looks like, I don't know, 0.6 in that first scatter diagram. But if we average all the A's and average all the B's and average all the C's, then we end up with that second graph, which has a correlation of like 0.99. Okay, so you have to be careful. Countries don't smoke. People smoke. Right? Countries don't have heights. People have heights. So when you crunch an entire country of people into one number or a set of numbers, that is called ecological data, and often the correlation coefficient jumps way up. So back to set E, is the correlation in figure 8 ecological? So we're looking at the death rates from breast cancer against how much fat is in their diet. Yes, it's ecological because they're divided into countries, and every country has its own scatter plot. And the correlation up there looks really high, like 0.8. But if we were to expand every country to represent all of the people, then the correlation coefficient would go down because it would be more egg-shaped. 3, the correlation between height and weight among men age 18 to 74 in the U.S. is about 0.4. Say whether each conclusion below follows the data. Taller men tend to be heavier. True. What is it about 0.4 that tells us that? It's positive. Okay? We don't know how steep it is, but 0.4 is positive, which means our football, which is more like an egg, our egg has a general positive slope to it, which means the taller you are, the more you're expected to weigh. B, The correlation between weight and height for men age 18 to 74 is about 0.4. I think it is 0.4, right? The correlation is 0.4. That's my bet. Somebody want to look in the back? I get things wrong all the time. So this is 9E3 letter B. What does it say? We're looking. It says true? Yes. No, I'm wrong. So is about 0.4. Oh, I know why. Why is it about 0.4? I think it's because we didn't talk to everybody, right? Well, no, I don't know. That one's tricky. Heavier men tend to be taller. True. Why? It's positive again. Was there an explanation on B? It just says true. Not sure. If someone eats more and puts on 10 pounds, he is likely to get somewhat taller. False. So does Y cause X? No. Does weighing more cause you to be taller? No. Could we say that getting taller causes you to weigh more? We could say that. But in the 18 to 74 group, those people are pretty much done growing. Okay. All right. Number 4. Studies find a negative correlation between hours spent watching television and scoring on reading tests. Does watching television make people less able to read? Yes or no? Probably explain yourself. Okay. So you watch so much TV that you no longer want to read. That could be it. What's probably happening here? So there's a negative correlation. The more TV you watch, the worse you are at reading. What's probably the explanation? Okay, which includes reading. So the people who read a lot are better readers, and they don't have to watch as much TV. Why not? Because they're reading. It's probably a time issue. Does TV directly lower your ability to read? No. If you have a Netflix marathon on Saturday, Monday morning, are you going to be a worse reader than you were on Friday? No. But over time, if you read a lot, you're going to be better at reading. And if you read a lot, you have less time to watch TV. So there is a correlation, a negative correlation between the number of hours that people watch TV and their reading ability. Can we say that TV lowers your reading ability? No. There's a confounding variable, which is time. The more you watch TV, the less you read. The less you read, the um, the worse you are at reading. Okay, but TV does not make you dumber. Right? Watching lots of TV can interfere with you becoming smarter, but you don't watch TV for 2 hours and then you end up, less intelligent than you were before. Unless, of course, you watch the cartoons that kids watch today. Man, there is no point to those. All right, that is 9E.